did you know that math can help prevent you from getting a sunburn?
No.
Who knew? Here's why. The time it takes to burn without sunscreen multiplied by the SPF. Now, you know when you buy lotion, sun lotion, it tells you the SPF. It'll say like 15 or 30. So the time it takes to burn in the sun times the SPF, or sun protection factor, is the time you can stay in the sun safely with your sunscreen. So how do we know what the time is that we can be in the sun safely? That every day there's a UV index given. And whatever that index is for that day. This is how long you can stay in the sun without being burned. So if the UV index is, let's say, 8, whatever SPF you put on, you multiply that by that number, and then it'll tell you how many minutes you can stay in the sun safely. Okay? So if today's index is 8, it means that, oh no, here you go. It means that she will burn in 15 minutes. So the index is 8, it tells you that that's 15 minutes for her to burn. If she will burn in 15 minutes without sunscreen, but she wears a sunscreen of 25, you will be able to figure out how long she's protected by multiplying the burn factor of 15 minutes times the 25 SPF factor. Yes?
Can't that also give you skin cancer?
Yes, but we're doing the math part of it right now. Okay, so let's look at the question over here. It says, underline the sentence that tells you how to find the amount. And it tells you right here, the time it takes to burn without sunscreen multiplied by the SPF. That's how you find it. So in the word problem, I'm underlining where it tells me how to solve my problem. Then it says, circle the numbers you need to use. Circle the numbers you need to use. We're going to multiply the 15 minutes times the 25 SPF. And then the last question says, what operation will you use? It tells us right here, what operation are we using? Multiplication. Go ahead and catch up with your pencil. Okay, so we need to multiply 25 times 15, and we can choose different ways to do it. We're going to do it 2 different ways here. We're going to try, what does it look like? What method does it look like they're going to be doing here? Partial product. So the first things we're going to be multiplying are the tens. 20 and 10. Multiply 20 times 10, and raise your hand when you know what that is. Okay, what is 20 times 10?
200.
200. Then we're going to do 10 from down here times this 5. What is 10 times 5? Raise your hand when you know. What is it?
50.
Okay. Now I'm going to do this 20 times this 5. Raise your hand when you know what it is. 20 times 5. Think about it. You need to think about it. Okay, what is it?
100.
100. And then the last thing we do is multiply the 2 5s. And what is 5 times 5?
25.
25. So now I can add those. I actually can add those in my head. 200 plus 100 is 300, 350, 375. And you guys could add that in your head as well. Okay? So partial products is one method. Put your pencils down. Another one we can do is to draw a picture. We can even do this to check our work. If we do the box method or the model method, whatever you want to call it, we're going to take the number 25. What's going to go right up here? 20. And right here?
5.
And here? 10. And here?
5.
There you go. Now remember, whatever box you're in, you're going to multiply the 2 numbers. I want the pencils are down. Whatever you're going to multiply, whatever box you're in, you're going to multiply the number that's above it and to the left. So in this case, it's going to be 20 times 10. What is 20 times 10?
100.
Let me ask the question first before you yell it out. In this box, I'm going to look up and left, so I have 5 times 10. What is 5 times 10?
50.
Let me finish my question before you answer it, please. In this box, I'm going to be multiplying 20 times 5. What is 20 times 5? 100. And then in this box, of course, is 5 times 5. What is 5 times 5? 25. Looking at these products in here, do you see that they match the partial products up here?
Yes.
We have 200, we have 50, we have 100, and we have 25. This is just a way of doing it without the model. This is a visual way. Some of you, this works better for you. So now again, I'm going to add that. 200 plus 100 is 300, plus 50 is 350, plus 25 is 375. Okay. So I want you, look, if you look down here where it says Math Talk, it says the product is 375. What did that mean? Do we remember what our problem was? If you can explain to me, what did the 375, what does that stand for? Preston. Yeah, the amount of time she can spend in the sun without getting a sunburn. If she has 375 minutes, how can we find out how many hours that is? Or about how many hours? What can we do to figure that out, Haley? Okay, round it, and then what would happen? This is minutes, so we need to convert it to hours. What do you think, Brian?
Just break it apart.
What does that mean by break it apart?
Break it apart. 300.
But then how will that tell us how many hours?
You do 375 minus 60 until you get to 0.
Okay, so he's going to take away 60 for each hour until he gets to 0. There's a better way to do it, though. You have the right idea. You would come up with the same answer, but there's an easier way to approach it. You would divide 375 by how many minutes? 60, because there's 60 minutes in an hour. Now, if this was me and I wanted to find out about how many hours, I would actually round this to a friendly number. What friendly number is going to be easily divisible by 60? That's near this number. We'll divide easy by 60.
400.
Not 400. There's one that's better. That's closer. Tony.
360.
Correct. 360 because 36 is divisible by 60. So how many times does, so here's something we can do too. We have 60 minutes, so we know that's 6 times 10, right? That's how much eats an hour. That's how many minutes are in an hour, 6 times 10. And we can do 36 times 10 is this number. Do you see why? You following that? So now I can get rid of these 10s because when you divide one and the other, they cancel each other out. And I can simply say 36 divided by 6. What is 36 divided by 6? 6. So how many hours?
6.
About 6 hours. She gets about 15 minutes more than that. But so 6 hours she can stay in the sun. All right, go ahead and write down, catch up with your pencil if you haven't already done. Use regrouping to find the 15 times 25. So this time we're going to do the same numbers, but instead of doing the partial product or the model method, we'll use regrouping, which is what we learned later last week. First thing we're going to do is estimate. If you round 15 to the nearest tens, what would it be? 15 rounds to 20. Now here's where it gets tricky. This one also rounds to, this one rounds to 30, but they're doing 20 times 20 here. Do you have any guesses why they decided to do 20 times 20 instead of 20 times 30? Because this really rounds to 30. Why would we maybe do that? What do you think, Preston?
Probably because it's hard to explain, but probably because it would be easier math.
Maybe because it would be easier math. Okay, like friendly numbers. Yes, Ethan?
Because all they did was they got rid of the 5 and 25 and added it to 15.
They kind of mentally moved it here. The 5 here does not mean the same thing that the 5 means here, but I'll explain. Hold on. It's a kinder, so they're not even first. Saw the blue, yeah. Okay. Great, thank you. Yeah, I will. Bye. Okay, so even though this is a 5 and this is a 5, we can't just move it over. It's not the same number. We are now not multiplying 20 by 20 legitimately. Do you understand what I'm saying? It's not like we can take the 5 from here and add it in here and have 20 times 20 and say, okay, that's going to be our answer. Because they mean different things where they are. But you can estimate thinking, well, this one, it's 5 is that midpoint, remember? So you can round one up and round one down and get a closer estimate of the actual answer. If you're rounding them both up, your answer is going to be way overestimated. Do you understand that? So rounding 15 up and rounding 25 up, we're going to get our answer is going to be a very overestimate. Rounding one up and one down, since they're both in the middle, would give a more accurate estimate of what we're looking for. Yes, Brian.
Can you just have the 25 and leave the 5 alone?
No. Oh, you mean just leave 20 times 25? Yeah, you can do 20 times 25. Sean.
Why didn't we make the 5 to 10? You put the 2 to 30.
I'm sorry. So make this 10 and this 30?
Yeah.
You could do that also. But, yes, Andy.
Is it because we ran 25 to 20 is because the 375 is the exact answer, so 400 is close to 375?
No, because we don't know the exact answer yet. I mean, we do, but we don't, right? We only do because we've already solved the problem. We're right now deciding another way to solve the problem. So we're pretending like we don't already know the answer. Okay? All right, eyes up here. So 20 times 20 is what number? 400. Okay, now we're going to go ahead and we're going to do our regrouping method. This is where a lot of you struggled last week. A lot. So I want all eyes up here and pencils are down. Okay, the first thing we're going to do is multiply the whole thing by the digit in the ones place. Remember, we can cross this 1 out and help us remember that we're just doing a regular multiplication. One digit times 2 digit, which you guys already know how to do. Okay? I could do 25 times 5 in my head, but we're going to go, and I'm sure many of you can too, but we're going to go through the steps. 5 times 5 is 25. Oops, that's a 2. 25. I need to regroup the 2 into the tens place. Now 5 times 2 is 10, and what do I do with the 2? Add it, so 10 plus 2 is 12. So 125. Or you could have thought quarters. How much is 5 quarters? Well, 4 quarters is $1, so one more would be $1.25. That would help you do that in your head. Okay? Now we're going to go to the other side. And we're going to multiply just by the 1 in the tens place. And you could make this 5 a 0 to remind you that you're multiplying by 10. Not just 1, but you're multiplying by 10. When you multiply a number by 10, you know that your last digit's going to be a 0. When you multiply a number by 10, I want eyes up here, you know your last number is going to be a 0. So I'm going to go ahead and put my 0 there, so I make sure I don't forget it, and then I'm going to multiply the rest of this out. The 1 times the 5 is
5.
And the 1 times the 2 is 250. Now let's look at this way. Let's look at it this way. This is what I was doing, where I'm doing 25 times 10. Raise your hand if you're not understanding why this problem is not, if you're not seeing the 25, it's 25 times 10. Okay, so let's go back here. What is the value of the 1 in this blue one? What is its value? 10. It stands for 10. So I need to multiply 10 times the top number. So 10 times 25. What is 10 times 25? Do it in your head. What's 10 times 25?
250.
250, which is what we came up with when we did it, when it was down here. Okay? Yes? So while I'm because it's 15 equals, if I put 15 in expanded form, what is it? I'm asking Brian. 10 plus 5. Now we've already multiplied the whole problem by the 5. Now we need to multiply the whole problem by 10. Because it's the value of that 15 there is 10. So if you had $15 and then you spent 5, do you only have $1 left? How much do you have left? 10. Because that 1 stands for 10, not 1. Right? So that's where I'm getting that is a 10. It's 10. Okay? So now I have 250 for my bottom number. What do I do with these two numbers now? Add them. So 5, 7, and 3. Oh, what a surprise. We got 375. Did anybody expect anything different? No. All right, now we can look at 375 compared to our estimate of 400. Is it pretty close?
Yeah.
Yes, it is. Let's go ahead and check. If we had done 20 times 30, think in your head, what is 20 times 30? 600. Is 375 anywhere near 600?
Yeah.
Not really. Which is why you learn to estimate. Sometimes when you're multiplying and you're to find an estimate of your multiplication, it's better to say, okay, these are both at the halfway point. I'm going to multiply one up and one, or round one up and one down to get the closest answer that I can. Yes, Haley.
I still don't understand why you changed 25 to
Well, I was just kind of explaining that they're both, the 5s are both at the half point, right? So if I'm going to round them, and I round them both up because the 5 tells me to round up, that's kind of our rule. If I round them both up, I'm going to end up with an estimate that is way over because both numbers are already over. I'm doing 20, which is over 15, and I'm doing 30, which is over 25. So my estimate's going to be way over my real answer. But since they're both at that halfway point, I'm gonna make a decision that one will round up and one will round down. So I'm gonna round this one up and I'm gonna round that one down. If we had done the other way, if we had done 10 times 30, let's say we rounded the 15 down and the 25 up, what would 15 times 30 be? 300, right? Is 300 pretty close to 375? It's a lot closer than 600, isn't it? So ultimately, it doesn't matter which one you're going up and which one you're going down, but just know that when both numbers are at the 5s, you can round one up and one down, and that'll give you a closer estimate. Okay? And I know that these are skills that you're learning that you guys would have learned in 3rd grade last year. So just kind of learning as we go. All right. We're going to multiply 57 times 43, and we're going to first estimate it. So right now, I want you to on your page estimate this right here. So you can fill in your pen, catch up with your pencil on this, and then do this part and then stop. 57 rounds to what?
60.
And 43 rounds to
40.
Okay. 6 times 4, listen to my question. 6 times 4 equals 24 times this 10 times this 10. Okay. Remember when I'm doing that, what I'm thinking in my head is that this number is 6 times 10 and this number is 4 times 10. So when I multiply, I'm doing 6 times 4, which is 24, times this 10 times this 10. And this is just a less work way of doing it is thinking, okay, times that 10 times that 10. Because I already can visualize in my head that this is what it is. All right, so my estimate is 2,400. Now I'm going to do it. Which method is it telling me to use here? Partial products. Okay, so partial products, what two numbers? I want you to think, what two numbers am I going to multiply first? Think in your head first. Raise your hand when you know which two numbers I'm going to multiply first. 40 times 5. So right here should be 40 times 50. I'm sorry, 40 times 50. What is, think in your head, what is 40 times 50? Don't tell me yet. I want you to really think about it before you say it out loud. Make sure you're really thinking about it. Okay, what is 40 times 50? 2,000. Remember, 4 times 5 is 20, times this 10 makes it 200, times this 10 makes it 2,000. Okay? Now, I've done the 40 times the 50. Now I'm going to do the 50 times the 3. So this equals 50, not 5. 50 times 3. Think about it in your head. What's 50 times 3? Okay, what is it? 150. Now I'm going to do this 40 times this 7. What is 40 times 7? Think in your head. Okay, what is 40 times 7? 280. There's no thousands involved. And if you're not sure, write it out. Do the first multiplication, and then times it times the 10, which would be 280. Sit up. Watch your zeros. All right, and then the last two numbers I'm going to multiply. I want you to think about what are the last two numbers I'm going to multiply. Let me know when you're ready. Okay, what numbers? 7 and 3. So 7 times 3 is 21. Now I'm going to add those. 1, that's a 5, 8, 9, 10, 15, 4, 2. So 2, 4, 5, 1. All right, go ahead and take a minute and catch up with your pencil. All right, now let's do the other one. What does it say which method to use for this one? Regrouping. So regrouping, we're going to start with multiplying the whole thing times just the ones place. When I'm multiplying 7, I'm going to multiply by what first? 3. Sean's the only one who seems to know. 7 times 3 is? 21. So the 1 goes here, we regroup the 2. Don't make it harder than it is, guys. Now I'm going to do 7 times what number? 4. There we go, which is? 28. 28 plus 2 more? 38. There we go. What number am I going to multiply by next? 50. 50 times 3. What is 50 times 3? 50. Remember, we're putting the 0 and the 5. Because we're in the tens place, this was another way I taught it last week. Because we're multiplying by a number in the tens place, my answer that I put down here can go up to the tens place. Everything else has to be regrouped. So 50 times 3 is 150. I can put the 50 there and I can regroup the 1 here. Now I do 5 times 4, which is? 20. Plus 1 more? 21. 1 plus 0 is 1. 5 plus 0 is? 5. There we go. 3 plus 1 is? 4. And 2 and nothing is? 2. There we go. All right, is 2,450, is that close to our estimate of 2,400?
Yes.
Yes, it is. So is the answer reasonable?
Yes.
How do you know your answer is reasonable? Raise a quiet hand if you can put that into words for me. How do you know your answer is reasonable, Malia? That's a wonderful answer. She said, I know that the answer is reasonable because before we did the problem, we estimated, and the actual product is close to the estimate. That'd be a perfect way to explain your answer of why it's reasonable, and I like how she restated it. So go ahead and fill in your number 1 with how do you know your answer is reasonable. And you can fill in this writing as well. Look at the partial products and regrouping method and above. How are the partial products 2,000 and 150 related to 2,150? Remember, we talked about this last week when we did this lesson. How are the partial products here, 2,000 and 150, related to this 2,150 here? How are they related? Sophia. Nice and loud, because like people are making a lot of noise.
If you do 2,000 times 150, you can get the answer.
You mean 2,000 plus 150 equals 2,150, doesn't it? So, in your own words, I want you to explain how the 2,000 and the 150 is the same as the 2,150 here. Go ahead and take a minute and explain that in your own words. And then I also want you to do the bottom one. How are the partial products of 180 and 21 related to the 301? All right, we're going to do this together. It says find the product. I am actually not going to tell you what method you have to use. I want you to choose a method and do number 1 on your own. Choose a method to find the product of that and go ahead and complete it. Here's the box for our model. What numbers am I going to put up here? If you did this, you can tell me. 50 and 4. Here's going to be 20 and 9. Okay, so 50 times 20 is not 10,000. It's 1,000. 5 times 2 is 10, times this 10 times this 10. That gives me 1,000. All right, now 4 times 20 is 80. 50 times 9.
450.
And 4 times 9. Okay, now I should be adding those numbers. I have 1,036. I'm just combining to make it go faster. 6, 8 and 8 is 16. 4, 5, 1,566. Okay, now if you did partial products, you will have the same numbers. You will have done 50 times 20, which is 1,000. You will have done 20 times 4, which is 80. You will have done 50 times 9, which is 450. And you will have done 4 times 9, which is 36. It's the same method. It's the same as this. It's just without the model. And then when I add that up, I get 1,566. Okay, so if that's the partial product, that's how, no, not right now. That's how you would come up with it. Now the last method is the regrouping. You would have done, leave the 2 alone first, do the 9 times 4, which is 36. Regroup. 9 times 5 is 45, plus the 3 is 48. I've lost some of you. Then I'm multiplying by 20, so I know that I'm going to need that 0 there. 2 times 4 is 8, and 2 times 5 is 10. If you notice, this number, 1,080, is the same as this, 1,080. 486 is the same as 450 plus 36. So you're doing the same things. It's just how your mind remembers how to do it. It gives you the different methods of how you do it. So then when I add this, of course, it's 1,566. Okay?